Alright, well, what we're going to do is we're going to talk about tangent lines and how to find them and use them to uh, find different values of a function. Now, a little quick review. When you talk about a tangent line, how do you find the equation of a tangent line? Now, this is a review and just get us warmed up. And hopefully you recall, in order to find an equation of a tangent line, or any line, I always say you need a slope and you need a point. Okay? I make this to my students. I really emphasize this because that is the essentials of Algebra 1 when you talk about lines. Now, to find the slope, we usually do y2 minus y1 over x2 minus x1. But here, since we're finding a tangent line, we discussed that finding this tangent line, we have f prime of x. That gives us our slope of f, of our tangent lines, most of tangents. Now, we are looking for a value at c, so that means I know my slope is going to be of this tangent line, f prime of c. My point that I'm going to use is, well, sometimes you have c as my x, obviously f of c is going to be my y, and that's what I have for there. Now, going on, define our equation of our tangent line. We have y equals f prime of c times, this is in point slope form, x minus c plus our y value, f of c. Now, some books put it on the other side, but this is how we write our equation of our tangent line. Okay, now, to use this, quick little introduction, is we're going to use something that's called linearization, or the tangent line approximation method. Now, what you may or may not know, okay, is that what do you notice about values of a function around x equals 2 and the values of a tangent line around x equals 2? Well, if I have two different graphs here, one is a tangent line around this function f of x, which equals x squared, and I created a tangent line at this point 2. Now, if we were to do this, we would find this tangent line, and I'll make this in green, okay? And to do that, we would find our slope, so f prime of x would equal 2x. To find my value, I would take that, and I would have, all right, find my slope first. Plug in f prime of 2, so I get 4. And then I find my point. Well, I have 2. I plug that into my function. F of 2 is going to equal, well, 2, 4. Okay? So from here, I can find this equation of this tangent line. So the equation of the tangent line is going to be y equals 4 times the quantity x minus 2 plus 4. Okay? And we can simplify that, put it in point slope, or slope-intercept form or whatnot. But I'm just going to keep it in point slope form. Now, from a far distance, you see that as this increases, as this line increases and gets larger in both directions, and it stays tangent, all right, we do that, you notice that the values that I plug into the tangent line are not the same values that I plug into the x squared, my parabola. But in further inspection, as you get closer to 2, now this is what we're doing, as we get closer to this tangent line at the point, all right, which is right here, round 2, what do you notice about the values? Well, I take this tangent line and I put it here, right on the value, is that you notice, and I'm just going to increase this, going forever, at 2, when we get closer there, is that actually the value are relatively the same. This point, there is very little difference between a point at 2, or let's just say 2.01. When x equals 2.01, I move this a little bit over here, put it on the tangent line, I put it on the actual graph, you notice that the values are pretty much equal. They don't get farther apart until we get to a farther, if I can imagine this going up, until we get a farther distance away. When we start plugging values a little bit farther away from the center point, where around x equals 2. And that's what's known as linearization, or tangent line approximation. Mathematicians determine that there is very little difference, all right, which is a differential, very little difference between the outputs, if you plug it into a tangent line, and the actual function around or surrounding a centered point, okay? And that centered point can be anything. Usually it's a whole number when we deal in calculus. But around 2, there's very little difference. If you go 2.11 or 2.01 or 1.9, there's very little difference between the value of that tangent line and the value of the function. And that's what's known as the linear approximation method. And in our next slide, we're going to try this out. So if we take this, we have our tangent line. All right, so, and if you can do this at home or go through, and you're going to plug in some different values. Okay, so we had 4, and it's going to be, we found that as our slope, x minus 2 and plus 4. Okay, so this is our tangent line, t of x. And let's plug in the different values. So if you plug into your calculator, f of x, which is x squared, and t of x, which is our tangent line, and we know that at 2, we should get a 4, and over here we also get a 4. But when you plug in like a value, let's just say at 1.9. So if you go to your calculators and you plug in a value, 1.9 into f of x and t of x, you realize you get 3.9601, and then you get 3.96. Well, you are close to the 10th, 100th, thousandths, to the 10,000th place, you're accurate. If you go to the other side, you realize you get the actual value is 4.0401, and this one is 4.04. Once again, to the 10,000th place, you are accurate up to the 10,000th place. That's pretty awesome. All right. If you go to 1.9, all right, you get 3.61, and here you get 3.6. So once again, you're pretty accurate. All right. A little bit farther apart, you get up to the 100th place, but yet still accurate. Here, I bet it's going to be the same thing, and yes, up to the 100th place. So what we have is a value that is very close to that. Hang on one second. So tangent line approximation methods allow us to find values of a function, all right, on certain surrounded points. So let's try. Sorry about that little interruption. It's not the best video, so I apologize. What we have is, let's try this out. Okay, let's practice using the linear approximation method. Here is a problem that a lot of folks will see. All right, what we have is a function. All right, and this is a little bit different. And we're asked to use differentials, which means tangent line problems. All right, use a tangent line. All right, use a tangent line to approximate f at f equaling 1.9 and f equaling 2.04. Now, if you notice in this problem, all right, we are not given the function f. We are not given a value that we can actually plug these values in. So we actually have to do some calculus. We have to actually use tangent line approximations and find the difference between them. So knowing what we know now, and that if we had a tangent line, if we found this equation of this tangent line, I call it t of x, or as some books call it L of x, this tangent line, if I found the equation of the tangent line, I could plug these values in as long as I found the tangent line around probably the center point, and since both these points are right around 2, 1. And that's what we're going to do. We're going to find the equation of a tangent line and then plug in those values into the tangent line to approximate the values of f of x. So let's first find this tangent line. All right, let's first find this tangent line. So to do that, we're going to find the slope. If you notice, we have this tangent line, rise over run. So find the slope, rise and run. So we're rising 1, running 1, so we have a slope of 1. We're going to take x minus 2 plus 1, so putting our point. And now let's use that equation right there to help us determine, all right, approximately what these values are. So I'm going to plug in 1.9 into this function right here. So I have 1.9 minus 2 plus 1. That's going to give me negative 0.1 plus 1, which is 0.9. So approximately 1.1, f of 1.1 is 0.9. We do the same thing now with 2.04 minus 2 plus 1. And what we have then right here is 0.04 plus 1, which is 1.04. That is our approximation of that value using linearization in the tangent line equation. Okay, so here's an example. We're going to have some more in some other tutorials, but this just kind of goes through an example and explains how you use tangent lines to approximate values of a function. This is called linearization or differentials, which different books call different things, but using tangent lines to approximate values of a function. All right, hope that helps. And look forward to the next tutorials.